In this video, I'll help you solve the ALEKS problem called predicting the products of dissolution. For this problem, you're going to want to have access to a periodic table. I really like ALEKS's periodic table for this problem because it color codes the metals and nonmetals. You're also going to want to have access to a table of polyatomic ions. I'm using the table of polyatomic ions from the website socratic.org. It's really nice. So for this problem, we've been given the names and formulas of 3 compounds, and honestly, the names are not important to us at all. We don't need to pay attention to that. And it's telling us that all 3 of these compounds are soluble in water, meaning that they will dissolve in water. It wants us to identify what are the major species present when the substance dissolves in water. So since this is dissolving in water, the very first thing that you should write down is water. Water is going to be present because you're dissolving it in water. Now what you have to do for the rest of this answer is you have to decide if this molecule is going to stay intact when it dissolves in water, or if it is going to split apart into a couple of pieces when it dissolves in water. And to help you make that decision, you're going to consult the periodic table. Now, in general, and I'm going to give you an exception to this in a minute, but in general, if the molecule is made up of all nonmetals, and that's one of the reasons why ALEKS's periodic table is great, because it makes it really easy for us to find the nonmetals because they're yellow. If the substance is, if the molecule is made up of all nonmetals, that means that that molecule is going to stay intact when it dissolves in water. And again, there is going to be an exception to that, so I'll put a little asterisk there. So for this first molecule that we're looking at, we have carbon, which is a nonmetal. We have hydrogen, which is a nonmetal. We have oxygen, which is also a nonmetal. All of them are nonmetals, which means the molecule is going to stay intact. And so we are just going to copy its molecular formula just right over there. And that's it. That's all that we have to do for that particular one. Let's take a look at the next one. So for the next one, again, always for all of these, water is present because you're dissolving it in water. And then let's analyze the atoms in this molecule. We have carbon, we have hydrogen, we have nitrogen. Again, all of them are nonmetals, which means that this molecule also is going to stay intact. Again, that means the molecule is not going to split apart into cations, anions, things like that. So let's take a look at my next example. Again, first of all, water, always present. What do we have in this molecule? We have sodium. We have carbon, we have oxygen. So here we have a metal. If there is a metal present, then the molecule is going to split into cations and anions. And this is where the problem can get tricky depending on the actual formula that we're dealing with. So for this particular formula, when I look at it, I see that I have a total of 3 different types of atoms. I have sodium, I have carbon, and I have oxygen. If I have 3 or more types of atoms, so I'm going to write 3 plus types of atoms, then that means that in my molecular formula somewhere, I have a polyatomic ion, and that is why it is handy to have this table of polyatomic ions while you're working on this problem so that you can consult it and find that polyatomic ion. Now, when we're looking at these molecules, because I can see that I have 3 different types of atoms, I know that I've got a polyatomic ion present. The atoms in a polyatomic ion stay together in a molecule. So that means my polyatomic ion is either Na2C or it is CO3. And I'm going to go to this table of polyatomic ions, and I just know from experience that my polyatomic ion is CO3. So that is that's how this molecule splits. It splits apart that CO3 polyatomic ion. We're going to write that, including its charge, as one of the species present in this solution. So that took care of that much of the molecule. Now the other portion of the molecule, we can see from the little subscript 2, we can see that that means that there are 2 sodium ions present in this molecule. If those 2 sodium ions stay together, meaning like if that's what the ion looks like in the solution, that would be a polyatomic ion, poly just meaning more than one, and it would be present on this table of polyatomic ions. But I'm looking here at the ends, and there is no Na2 ion, so that tells me that this is not the Na2 ion, but rather it is 2 of the sodium ions. That 2 there is to indicate the quantity. So I know that I have sodium ions present. ALEKS does not want you to indicate the quantity of ions in the answer, so it doesn't want you to put a 2 here. We're not going to include that. It just wants to know what they are. So I know I have the sodium ion present, and my last job is to figure out the charge on the sodium ion. Periodic tables are really handy for us to predict charges because a lot of the elements on the periodic table are in columns that have predictable charges associated with them. So for example, everything in the first column, when it ionizes, it forms an ion with a +1 charge. These guys form an ion with a +2 charge, and you get the idea. There are some columns on the periodic table where we can't make predictions, but sodium is an ion in a column that has a predictable charge of +1. Now, I did say that there was one exception to this. I got an asterisk and everything. If the compound contains all nonmetals, then like we saw for our first two, that formula is going to stay intact. One exception that you need to look out for is the NH4 plus polyatomic cation. So for example, NH4 could look something like this, NH42CO3. This is all nonmetals, nitrogen, hydrogen, carbon, oxygen, all nonmetals. However, this is ionic and it splits up. So if you have the NH4 group, this is going to cause the molecule to split into cations and anions. And so that is one trick that one thing that you need to look out for that's going to be pretty tricky. If you have nonmetals, double check and make sure that you do not have the NH4. And if you do have the NH4, then it is going to split apart just like it would if there was a metal present, not going to stay intact. Nonmetals, molecules that are all nonmetals that do not contain the NH4 group, those are the ones that stay intact.